calculators. So, last hour we only got through one graphing problem, and there's 4 of them on there. So, let's get moving. So, we're going to talk about 2 things today. We're going to talk about what parabolas look like and what their equations look like. There's 2 different forms. And then we're also going to talk about graphing them. So first let's talk about what they look like and what their forms are. So a vertex and axis symmetry. Every single parabola. That's what a quadratic equation comes out to, is a parabola. Every single parabola or quadratic equation looks like this, where it opens up, or goes up, right? There's 2 different ones we're going to deal with. They do go side to side. We are not going to see any of those. We're only going to go with up or down, okay? So each one has a vertex. The vertex is either the highest point in your parabola or the lowest point on your parabola, depending on what it looks like, right? If I have a parabola that goes like this, like the one in the picture, my vertex is my maximum point. It is the highest point on the parabola or the quadratic function. If I have a quadratic function that goes like this, my vertex is the lowest or the minimum point of my parabola or my quadratic function. Alright, so your vertex can be one or the other. It can be maximum or minimum, depending on what your graph looks like. Now the axis of symmetry is the line of symmetry that cuts a parabola evenly in half. If you look at these, I should be able to, when I graph, fold it over, and it should line up right with the other side. They are symmetrical. Right? So the line of symmetry, the axis of symmetry, cuts right through your vertex. Straight up and down. You should be able to fold right over that, and it should be the same on either side.
Like a piece of paper?
Like if you take a piece of paper, you fold it in half, fits, right? Our parabolas or quadratic functions should do the same. Okay? So first of all, this is standard form. Y equals ax squared plus bx plus c. Standard form. That's what we call that. Alright? So, you'll notice, I said we have 2 different ways we can draw our parabolas. That is based on our a value out front. The number in front of x squared. If it is a positive number, it is going to open up. If it is a negative number, it is going to open down. The way I like to remember it, and if you want to think of it this way too, if a is positive, it makes a smiley face. Positive, smiley face. If a is negative, it makes a frowny face. So if it's a negative, it frowns. If it's positive, it smiles. Right? That's the way I like to think of it. It helps me think of it that way. If you want to, you can think of it like that, or don't. I really don't care. Okay? So, that's a big thing when you're graphing. You got to figure out, well, is A positive or negative? Which way is it going to go? Cool? Any questions so far? Have I missed anything yet? No? Now that you guys know at least, right? Alright. So, standard form. Ax squared plus bx plus c. A, b, and c are all constants. What are constants? In math, what is a constant? What's that?
Something that goes on.
Not something that goes, I mean it could go on, but
Something that
That
doesn't
stops at a
stop.
certain point.
something what?
Something that stops at a certain point.
Not stops at a certain point. I kind of like what you said, Abby. What'd you say?
She laughed.
It stays the same.
Something that stays the same or doesn't change. It's a number, right? The number 3. Is that ever going to change?
No.
No, right? Is the number 7 ever going to change? So A, B, and C are always numbers. They're constants. They're not changing. Right? So ax squared plus bx plus c equals f of x. To find your axis of symmetry in standard form, you're going to do x equals negative b over 2a. Right? This is going to be a formula you're going to use a million times. So please make sure you circle it, start, do something with it. To find your axis of symmetry, you're going to do x equals negative b over 2a. Then to find your vertex, your x value, you just got it. When you did your axis of symmetry, you just got your x value. To find your y value, you're going to take that x value, whatever you get from this formula, plug it into your equation, and that gives you your y value. Alright? Let's try it. F of x equals x squared plus 4x minus 12. Now the first one, I'm going to write out what a, b, and c equal. I will not do this most of the time. Right? My a value, remember it's ax squared plus bx plus c. So the number in front of x squared, that's my a value. What number is out there?
1.
1, right? It's imaginary, so it's just 1. Nothing out there. What's my b value?
4.
4. What's my c value? Negative 12. Right? So, ax squared plus bx plus c. So if I want to find my axis of symmetry, it's alright, I figured it out. I'm going to do x equals negative b over 2a. Oh, I said my b value was 4, so negative 4 over 2 times a is 1. Right? All I did is I took b, plugged it in where it said to, a, plugged it in where it said to. Well, what's 2 times 1? 2. What's negative 4 divided by 2? Negative 2. So my axis of symmetry is x equals negative 2. If you just put negative 2 on the test, it will get marked wrong. Because your axis of symmetry is a line, it needs an equation. So x equals negative 2. Then, when I'm trying to find my vertex, my x value is going to be at negative 2. And to find my y value, I'm going to take this negative 2, and I'm going to plug it in for all the x's in the equation. Negative 2 squared plus 4 times negative 2 minus 12. All I did is took my x value, plugged it in. Okay? Negative 2 squared is 4. 4 times negative 2 is negative 8. And minus 12 stays. Well, 4 minus 8 is negative 4. Minus 12 is negative 16. So my y value is negative 16. Now I found my vertex and I found my axis of symmetry. That's how we do that in standard form. That's the first form you'll see equations written, in standard form. Any questions on standard form? There is another version. It's called vertex form. So, vertex form is in the equation f of x equals a times x minus h squared plus k. So this is the second form. Now the nice thing about this form is our vertex is hk. So it's given to us in our formula. It's given to us in our equation. We don't have to do any computations to find our vertex. Alright? So all we're doing is we're pulling h and we're pulling k and we're making our vertex. So let's try it. F of x equals x plus 5 squared minus 2. Now remember, we just said a times x minus h squared plus k. Be very careful when you are pulling your vertex out. We said it's going to be h, comma k. Notice this says x minus h. This says x plus 5. Do you think I should just take 5 then? If I plug 5 into here, do I get x plus 5? If I plug 5 into x minus h, what do I get? For h. Plug 5 in for h. What do you get? X minus 5, right? Is that what I'm looking at here? No. What's going to happen, guys, is we are always going to take the opposite of what's in here. So not positive 5, but negative 5. And we're going to take the number that is out here. So we're going to take negative 2. So we're taking the opposite of what's inside the parenthesis, which is negative 5. Or we're taking whatever's outside the parenthesis, which is negative 2. That is my vertex. Negative 5, negative 2. Yes, ma'am?
Do we always take the opposite of what's in the parentheses?
Always take the opposite, because remember our equation started out as minus h.
So what if it were to be x minus 5?
Well, then we would take positive 5. So if I plug positive 5 in here, I get x minus 5 then. Okay? So it's always the opposite of what's in there. Our axis of symmetry, guys, we said is always x equals whatever number this is. So our axis of symmetry is x equals negative 5. That's not so bad, is it?
Terrible.
No.
Are there any questions? So that's our second way that we can see or our quadratic equation written. Standard form, vertex form. Okay, any questions? Then let's get to graphing. I believe that's our next step here. Okay, I'm going to talk very briefly about this slide. It does have some good steps, right? The steps to graphing. Look at your vertex, start with that. If you do anything at all, start with your vertex. Do that right. Because if your vertex isn't right, nothing else is going to be right, because everything builds off the vertex. So make sure you find your vertex correctly. Step 2, look at the value of A, determine if it's going to open up or down. We'll also do that when we do our plug and chug to find our other points. And plot the other points from the vertex. So, here we go. Graphing, our first equation here, x squared plus 4x minus 2. Find the vertex first. In standard form, we said we start by doing x equals negative b over 2a. Right? That is the first step from standard form. Well, in this equation, what is my b value? 4. So I'm putting negative 4 over 2 times, what's my a value? What's the number in front of x squared? 1. So I get negative 4 over 2. So x is negative 4 divided by 2 gives me negative 2. So in my vertex, I have negative 2, comma, blank. How do I find that blank? How do I find the y value? Plug it back in. So take your negative 2, plug it into your equation. Negative 2 squared plus 4 times negative 2 minus 2. Negative 2 squared is positive 4. 4 times negative 2 is negative 8. And then minus 2. So 4 minus 8 gets me negative 4. Minus 2 is negative 6. So my y value then is at negative 6. So negative 2, negative 6. Did everyone see how we found both the x and the y value there? Yes? No? Okay. Then I'm going to plot that point. Negative 2, negative 6. And I put my point. That is my vertex. That is the most important point that you will put on there. If you mess that up, everything else goes out the window. Yes, Cal?
Now do we go like we here?
Well, I'll tell you how we get the next ones. Okay? Now, you also need to draw your axis of symmetry on there. It is a dashed vertical line through your vertex. Your axis of symmetry is a dashed vertical line through your vertex. That's the second thing you should draw. Okay. Then we need to find a few more points. Alright? To do that, I'm going to look. What x value is my vertex at? Negative 2. I'm going to go 1 to the right. What is that then for x value?
Negative 1.
Negative 1. So I'm going to let x equal negative 1. And I'm going to plug that back in to find a y value. Yes, Carl?
Should there be arrows at the end of the dash line?
Yes.
Okay.
You can put arrows. If you don't, I'm not a big stickler on that, but yes, there should be. Okay. So I started at x equals negative 2. I went 1 to the right, which gave me x equals negative 1. Plug that back in. Negative 1 squared plus 4 times negative 1 minus 2. Right? Any questions before I move on?
Wait, why did you get negative 1?
Because I started with x equals negative 2 here for my vertex, right? 1 to the right. What's the x value there?
Negative 1.
Negative 1.
Why do you go 1 to the right?
Because, I mean, you can go 1 to the left if you want. I always go to the right, and then I'm going to mirror it in a second. Okay? Okay. Negative 1 squared is?
1.
1. Thank you.
You're welcome.
4 times negative 1 is?
Negative 4.
Negative 4 minus 2.
I agree.
1 minus 4 is negative 3. Minus 2 is negative 5. So that's my y value. So at negative 1, negative 5, I have a second point on my parabola, or my quadratic equation. Okay? Yes? No? negative 1, negative 5. And what I can do, guys, because we said it's like a mirror, I can take that point and mirror it across my axis of symmetry. It's symmetrical, right? So I can take it and mirror it across. You need 5 points to graph your line. 1, 2, 3. I need one more. So now I'm going to go one farther to the right. What x value is this? 0. So I'm going to let x equal 0. Plug it into my equation. 0 squared plus 4 times 0 minus 2. Well, 0 squared is 0. 4 times 0 is 0. Minus 2. So I get negative 2. So that's my y value. So at 0, negative 2, I have another point. 0, negative 2. And once again, it should be like a mirror. I should be able to mirror it across. Once you have 5 points, you can draw it in.
That's like
Our graph should look like that, right? Up here, past those points, like obviously don't try and make them connect. Try and make them keep going out, but they don't have to be perfect, okay? Those 5 points, what we need, a vertex and 4 others. Alright? Cool?
Maybe.
Do we need to do like a straight edge?
Can I keep that there for a second? Yeah. What's that?
Do we need like a straight edge, because that's kind of impossible.
You do not need a straight edge, no.
Like this.
No.
Can we get these equations on the test?
I do not think so.
Just write it down.
Okay. Andrew, you need up there still?
you're fine.
Are you sure?
You can.
It's like if you want.
They'll be posted, the notes will be posted to Schoology too. So if you need to copy them off. Alright, so next one's in vertex form. Let's do this one quickly so we run out of time here. So, this one's in vertex form. Remember, a times x minus h squared plus k. So what is the vertex? Find it first. So we're taking the opposite of what's in here, so negative 5.
Negative 2.
And we're taking the number that's out here, negative 2.
Isn't it literally just...
It's the same one we just did. Yep. Negative 5, negative 2. So I'm going to plot that point first. 1, 2, 3, 4, 5. 1, 2. And I'm going to draw my axis of symmetry right through it. A dashed line right through it. Axis of symmetry then would be x equals negative 5, right? It's x equals our x value. Okay, I need 4 more points. So just like I did before, my x value started at negative 5. I'm going to go 1 to the right. Which that would be x equals
Negative 4.
negative 4. I'm going to go up here. Take negative 4. Plug it into this equation. 2 times negative 4 plus 5 squared minus 2. Take them step by step. What is negative 4 plus 5? 1. So 2 times 1 squared minus 2. Next thing, the exponent. What's 1 squared? 1. 2 times 1 minus 2. 2 times 1 is? 2. 2 minus 2 equals? 0. So at negative 4, oops, 0, I have my second point. Negative 4, 0 is my second point, and I can mirror it. Remember, anything across there should be a mirror. Okay, now it's at negative 4, so I'm going to go one more to the right. It's at x is negative 3. Plug that in. 2 times negative 3 plus 5 squared minus 2. Right? Plug it into your equation, find your y. Negative 3 plus 5 gives me negative 2, or excuse me, positive 2. Squared minus 2. What is 2 squared?
4.
4. So 2 times 4 minus 2. 2 times 4 is 8. Minus 2 is 6. So then at negative 3, 6, I have another point. -3, 1, 2, 3, 4, 5, 6. Mirror it across and draw it in. So the one question we didn't answer, does the graph open up or down? Opens up, right? It's a smiley face. Is there a way you could have figured that out? Oh, it's ugly to you. Without drawing the graph?
Yeah.
Remember, we look at the A value. If the A value is positive, it opens up. If the A value is negative, it opens down. Alright.
What does that mean?
I'm sorry, that was a rush to get through. Right, we didn't even get through all the graphing problems.